A warm welcome this Wednesday morning to all of you, and especially welcome Diego and Mats. How are you today? The quiet you are.
Well, it feels like it's Monday. Well,
It feels like Monday. Is it a typical
yeah.
Monday? A Monday, Wednesday?
Yeah.
Yeah. And you, Diego, you good?
Yeah.
Nice to hear.
Everything okay.
Yeah. So we will dwell right into it because we have kind of a lot to cover today, and we will start with your stuff, Diego, and basically the first assignment. So a new deadline is coming up. I should have prepared this, but soon it will be coming up, kind of right now. So looking at the first assignment, I have a... it worked. Assignment 1. There is the resubmission deadline. It's the 10th, so it's this Friday. So for submission of the first assignment, it's now on Friday, and that is probably the same, Diego, for complementary work on for those who submitted on the first deadline, right?
Yes. That's what I expected.
Yeah. Good. So just be aware of that deadline. Next deadline is the 17th of June. So I mean, try to really work to get this to meet this deadline on Friday. Anything else to add to that? Any questions that has arisen or something like that?
No questions, and some of the students who needed complementary work, it was a small addition, and they did the same day. So I saw their request and comments that I could review it the day after I gave the feedback. So I will do it, and I will start on next Monday with everybody together. But yeah, it was some of the complementary works, they were very small complementary work. They lack a little bit to make the code work.
I get it. Okay, but then leaving assignment 1, going to the second part. Now things have really started to happening. We are on the orchestration part of things, and I know that a lot of you have worked with this one, the Kubernetes development part, in the local part with Minikube and Scaffold and Docker, of course, installed as well. And there is one problem that Theodore reminded me of that no, it's not connected to this one, actually. Never mind. I will get to the other problem later on. I got some questions about when you start Minikube, the Minikube tunnel. That is the tunnel into the cluster. On Macintosh, you should get a question of entering your password, and then it's the password for your local machine. Basically, you must elevate your permissions to be able to execute something on a privileged port, and that is, I don't remember the exact port numbers, but under a certain port number, everything is counted as privileged ports, and that includes port 80 and 443. So in the case of Minikube, it will open up on port 80, so you can just write localhost in your web browser and visit your application. And to be able to do that, you need to write your password for your computer. It's not another password. It's not CS Cloud. It's not or your LNU account or something like that. It's the local password on your computer. When you write that, it's like in the terminal. You have probably seen that before. But when you write a password, you don't actually see dots or something. So you just copy and paste the password in or write it in and press enter, and then you have written your password. And in that case, if nothing happens, that is actually good, because when you have written the password, it's just a blank line and it seems like nothing is working. But when you actually try to visit localhost, it should now be open and ready to accept traffic. So it's a bit confusing with that one, but it should work at least. I don't think, Mats, have you tried Minikube on Minikube and the Minikube tunnel on Windows? If you get the same,
No, not yet this year.
no, but I don't think actually you get the system dialog there. I think you are able to open it on port 80, which I think so at least. So this one was for being able to take an application that is developed for a cluster and work with it in a local environment. So you can have like tens of services running on your computer inside of Minikube and work on those. Next step is to put this on a Kubernetes cluster in production. And this one has been revised. So if you don't have this picture, if you have an older picture, please just do on a Macintosh shift command refresh so that you empty the cache in the browser, because the Gatsby that we are using is pretty heavy on caching. So sometimes it caches a little bit too much. So in this one, we are going to create an infrastructure looking like this. And of course, you can do this from scratch. You have all the tools for doing this. But since this assignment is not about creating the infrastructure, you have done that in the first assignment. So now we have provided you with a script for creating just this. And Mats, this is the example Kubernetes cluster infrastructure, and you have put a lot of effort into this one, making it really neat to work with, especially when it comes to like trying to get rid of IP addresses, so you don't need to remember too many IP addresses working in the cluster. You can just call things like Kubernetes control plane 1, then you can just do an SSH Kubernetes control plane 1, and you don't need to remember that password. So it's really neat. Should I explain, or do you want to explain this, like what everything is doing?
You can explain.
Yeah, and you can correct me
if necessary.
Yeah. So what we got here is we got two separate networks, and we do this because this Kubernetes network, the green one, is like isolated from the jump host network, and the jump host network is basically our entrance into the green one. So we are not able, from the public internet, we are not able to reach you on port 22 at least. We are not able to like SSH into the control plane or the Kubernetes cluster. We need to go through the jump host in this case. The jump host is just a Ubuntu machine, but with certificates in place to be able to connect to those nodes. It also has some neat tools installed. We can use this one for provisioning and doing stuff with the Kubernetes network. So instead of doing that from our local machine, we can use the jump host for everything. And it's actually
it's not the final design, we should say, I think, but it's good enough to use now. Well.
And the reason why it's not the final design is that we have on the inside, on the green network, we have a Kubernetes load balancer. This one can communicate to the public internet through port 80 and 443. And all of those nodes can communicate, and the control plane can communicate out and fetch stuff like containers in GitLab and whatever. So what we are looking into doing is adding a proxy where we can specify more in detail what those load balancers and workers should be able to connect to and not. But that is
another shortcut is that the jump host stores the private key to the Kubernetes cluster. Not optional, but well, we like it to be easy to use this. So that's a design decision I made.
Yeah. Otherwise, what would we do in other places, like have a certificate server and use certificates and things like that, or?
Or you pass it along when you SSH.
Oh, okay. Okay, but I think it's really convenient to have it in the jump host. So now we can just protect the jump host. If the jump host is protected, we are kind of safe. So we don't need any keys on our local computer, more than being able to connect to the jump host. And you have configured it so that the jump host will have your private keys for CS Cloud in it when you run the Terraform scripts. If you have configured it correctly, it should all be up and running, and now you don't need to do a lot of things after you have run Terraform. However, we will not go through this. I think we talked about it last time, but make sure to read this and follow these guides, because there are some steps. First of all, you need to configure this with your keys and your identity file and things like that. You have written it in both in Bash and PowerShell, so this should be. I follow these instructions and they are really good. Then you run Terraform, and after that you connect into the jump host with SSH, and then you can run the CSW command. Is that a Cloud Init command, or is it something you have? It's a script you have created. Okay, so it will basically
what it basically does is to call what's Cloud Init status wait.
Okay, yeah, it says here. Yeah, and the thing is that when you have executed Terraform, the last thing that it will start to do is to provision all the servers. But that will take some time, and they will restart and things like that, and you have no idea when they are finished, unless calling this command. But you have made a shortcut CSW. So you just go into the jump host, write CSW, and then you will probably lose connection. If you see those dots, you will lose connection sometime. Then you need to SSH into the machine again, run it again, and then it should say something like this: Cloud finished on a local machine. But then you can run CSW-F, and then it will look at the provisioning for all of the worker nodes, the control plane, and you will see what is happening on those nodes. And after a time, this will stabilize in a Cloud Init finished on all the servers. Then you know, okay, now we can continue to the next step. Now all servers are up and running. And it's pretty quick, I would say. It's like
also about 5 minutes or so.
Yeah, and
or less.
And that makes it really convenient. You can just put it down and make it go up again. So I have probably tried it like 5 times or something like that in my account, and it worked flawlessly every time, not a single error. So I had an error once, but that was because I was sloppy and didn't remove all the servers and executed it, and then I got some problem with some known hosts and stuff like that. But if you just tear everything down, then it will work to get it up again. Then, after it's finished, then you need to create the cluster to make sure that all the worker nodes are connected in the cluster, and that you have your 2 control planes and things like that. And that you also made a script for, so node join cluster -f, and then everything will be set up. So you need to run this command, or manually set up the cluster, like run the commands. But then you need a lot of IP addresses and stuff, I guess, to do that. After you've done that, you should be able to do a kubectl get nodes, but you cannot do kubectl on the jump host. You must do that on the control plane, and then you just do an SSH. You actually don't need Ubuntu. You just do an SSH, Kubernetes control plane 1, and then you run this command, and then you will see this. So you can either just SSH into the control plane and run the kubectl commands, or you can do that from the jump host, whatever you like. After that, we need to configure Nginx as a load balancer, and there is a script for that as well. So you just execute that script. You can wait with this if you like when it's time to publish your page, because you will still need to go into the Nginx file and temper it and add a port for the ingress controller. But I cover that in the exercise. And jump host, the benefits for the you have written some text about this as well. Anything to add?
I don't think so.
Nope. Great.
Okay, this is the first, or maybe
the second iteration.
The previous year. So this is the second iteration, but a lot of work, I think, remains to make this perfect.
Yeah.
Well,
like the commit
it's
messages.
Good enough.
Yeah, like the commit messages. We have done a lot of commits, so that's why. So first step in this part, the production part, is build the infrastructure. And when you got something like that, then you can go further and connect your cluster to GitLab and deploy. So I will just briefly talk about this, but you can just follow this guide. Mats is doing it right now. He will let me know if something is unclear, I hope. But I've tried it a couple of times.
I'm editing it right
as
now.
we speak. Okay, so there might be updates when Mats is doing
point
this.
3.
It's hard to write everything correct from the beginning when you do guides like this. So first of all, GitLab has a way to communicate with Kubernetes clusters built in, and we will utilize that because that will make it really easy to put things on the cluster. So you basically just follow along and create a CS Cloud agent. You install this agent in the cluster, and you will get instructions for that on GitLab how to do that. It's a Helm chart. Helm is installed in at least at the control plane 1. Is it on control plane 2 as well? Helm?
Nope.
Nope.
It's K8S control plane 1.
Yeah. So you need to go into the control plane 1 and execute the Helm charts. After that, you will, when you build your containers, they will end up at the GitLab container registry. So the container will not be at your local computer. It will end up in the GitLab container registry when you run this in the pipelines. But you need to set up deploy tokens for this, and these are the instructions for that. It's pretty straightforward. When you run and deploy the pipeline, everything after that should work pretty neat, and you should hopefully see something like this in your cluster, where you have one instance of MongoDB and one instance of Taskit. If you curl this one with the port, it should get you the application in the terminal, and then you know it's up and running and everything is working. However, we will not be able to reach this from the outside. It will only say bad gateway if we try to connect to our load balancer. So now we need to set up an ingress controller, and we will do that using Helm as well. So we will install the Nginx ingress controller. We didn't do this last year, for those of you who follow the old guide, because we didn't get it to work. Now it magically works after some research. There are other ingress controllers as well. You don't need to use Nginx. However, it worked really neat. And you install the ingress controller, and after that you will get this, I called it web, and you will get the web ingress Nginx controller and an emission, whatever that is. It will have a port number here, 30, in this case 3411, and that one you need to take notice of, because that's the port you need to add to your load balancer, because that is the node port that is available from the outside of the cluster. And yeah, we try that we can connect using the Nginx controller, and then we go into the load balancer, we edit Nginx config, and we add those port numbers to the server. Not 100% sure that this is the best way to do it, at least of right now it works. However, it would be nice to have some magic involved between the load balancer and the ingress controller so they can talk to each other. But that's for further homework to make that work. If you were to run this in like Google Cloud or AWS will like have services that will talk to the ingress controller and give it an IP and everything automatically. So then you don't need to think about this. However, in this case, we need to do that. After that, we restart the Nginx service. You should now be able to connect to your Taskit service using through the load balancer from the public internet. And then I have some information about creating secrets, because maybe the session secret should not be stored as an environment variable. We should use it as a secret in the Kubernetes cluster. So this one you should do as well, because you will have to do that in the assignment. So, but then you know where to find out how to do that as well. So basically, this is the production part. It should be pretty straightforward if you use our examples that are available on GitLab, Mats infrastructure project, and then my code project, where scaffold files, Kubernetes file, everything is ready. You're free to do this any way you want. You can set it up from start to finish if you feel that you have the time. But it should be pretty much more straightforward this year than last year. So, any questions on this or comments? Because this is the first step in starting with assignment 2, and I will present assignment 2 now. And I know that you have to run Diego soon, so you will probably do something like that and disappear somewhere in the near future, but that is totally fine. Yeah. Okay, so then we go into assignment 2. And assignment 2 has a deadline on the 24th of November, so it's after you are finished with the orchestration part, you should start working on the assignment. It's pretty much just a extension of that exercise. So we will have a look at this one now. First of all, maybe I can have it like that instead. First of all, note that in the repositories that you have got pushed out to your GitLab accounts or GitLab student GitLab projects, you find a report file and you find a README file. The README file is the instructions. The report.md file is the report you should fill in when you have created the assignment. So we will have a look at that as well. But the assignment itself, it should be an extension of the example application. And the example application, I think this one is linked incorrectly in your README files that has been pushed out. However, if you visit the course web page or you go into the template on GitLab, you should find a new link. And the link is to... It should look something like this with the Kubernetes logo, and it will soon not say VIP anymore because I have just some few things to fix in this one. But it's the Kuberneterized web application you should use, not the old one that is deprecated. So make sure that you use this one, the Kuberneterized web application instead. So just be sure that the link is wrong in some of the repositories. The application should be continuously delivered to a Kubernetes cluster using a GitLab pipeline, basically what we did in the second exercise. But then we will do some extensions. The Taskit service should not be stateful. So we have a problem with the Taskit service as it is right now. If you create multiple replicas of the Taskit service, you will notice that something is behaving really strange. You kind of add stuff and then like you do another thing, and then just a few calls later, pop-ups will appear with like saying, "Oh, thank you for adding this," and so the Flash messages are not in sync, and you will see that it's really strange, and that's because the load balancer will probably direct the traffic to different tasked services in the cluster at different times, and then you will get this result. And the problem is that the tasked service as of right now is stateful, and it should not be. The problem is not the MongoDB, because that one is separate from the tasked service, but the problem is the sessions. So you will have to handle the sessions in a key value store of some sort. It's not okay to handle the sessions in the in memory as it is right now. So you need to set up a key value store. We recommend setting up it as a Redis key value store. It's the most common way to do it, and you will also find down here recommended techniques. You will find a link to Redis and how to set it up as a session store. You can set a MongoDB instance up as a session store if you like. However, I would not recommend using the same MongoDB database instance as where you have stored the data and use that as a session store. It's better to separate those, so you have a separate MongoDB instance that is the session store and a separate one for the data. But in use Redis, then you have, then you can add another tool to your CV as well. So that is what we need to do with the tasked service. Anything to add there, Mats?
I don't think so.
No.
It should be pretty straightforward this year, I think.
Yeah. And just remember that the tasked service, we have modified it since you used that one the last time. I think it was like in the second year, but you have added logging as well, Mats, to the tasking service. So I wouldn't be surprised if next year we also have some kind of arrow going to logging in this case, so we can handle the logs outside of the cluster maybe, but we are not there yet.
But we have a plan.
We have a plan. Then we have on the right side, we have the new functionality that isn't written yet. So the thing is that as soon as someone adds a task or removes a task, it should be notified in Slack. And there is a channel set up called, I think it's also mentioned here, it's called 2DV notifications, 2DV013 notifications. So you can actually visit that in Slack, and then that is where all notifications should show up. I can give you one tip, and that is to mute that channel immediately, because it will otherwise just drain you with notifications. So how should this work then? Well, the tasked service should not just call the Slack service directly. We should do this in a better way. We will introduce a notification service. So you need to write a service that is responsible for communication with Slack. What you use for techniques, languages, doesn't matter. You can write this in Java, you can write it in JavaScript, you can write it in Python, Rust, C#. Do whatever you like. Yeah, it's a pretty small service, actually. It's not many lines of code, so don't be afraid to try it out in a new technique. And the tasked service will not communicate with the notification service directly. Instead, we will have a queue in the middle. And if you read in the course literature, you will find that it should be an asynchronous single receiver pattern that is implemented between the tasked service and the notification service. So you need to read up on that as well. The queue here, we recommend using RabbitMQ. And RabbitMQ is also listed down here. But there are other queues. I think Kafka is one, and there are others that you could probably use for the queue. We don't specify. You should just implement it as a queue. Don't write the queue yourself. Use a service for that. That is already existing. Next up. Going through, let's see, continuous delivery, task it service. Here are the requirements. The sessions are stored in memory and not in session store. A must fix. You must fix that. No notifications when a task is completed. That is a problem right now. You must fix this. The data should be persistent. That is a must fix. I didn't say that. The data store here, the MongoDB store, you need to set it up on a volume so it have a volume claim and the data is stored on a persistent volume in the cluster. So there is a recording for that as well, but that should be fixed as well. As of right now, there is no authentication authorization on the Just Task It. This is not, you have written authentication protocols before and you have fixed that before, so it's just an optional fix. If you like to fix it, you're fine, free to do so, but it's optional. Then we write the first flaw is using a key value store. The second problem you should address by using the asynchronous single receiver pattern. The third flaw is using data store persistent data on mounted volumes. So that is what you're going to do. Then we have the notification service. You have the requirements how it should work. You should use the commands created, completed, and uncompleted. And there are some examples. And yeah, as I said, to spice it up, try to use like Express, something else than what you have done right now. Maybe Express is not a good choice anyways. So this is the assignment, and this of course should be published in the CS Cloud or any other service for that matter, and you should be able to have some kind of triggers in the pipelines if you do a push or a merge request or however you want to set that up. The easiest when just testing is probably to just have it on a normal commit. So when you commit something, it will build the services and set it up. And you should also be able to start like 3 taskit services and like 3 notification services, and this should work anyway. So when you're configuring those services, set 3 replicas. There is no need to have replicas of the MongoDB, but if you want to try it, you can do that already. You will do that in the group project later on. Then you will have database replicas as well, but not in this assignment. Yeah, anything to add, Mats? Or Diego?
No, I don't know if we should mention something about that we are updating, that we have updated the key.
Yeah, good. So the key, in the secrets, when
token, access token.
Yeah, when connecting to Slack, you will need a token for that, and that token is available in your secrets project at GitLab. But you have updated that now, Mats. So the token you will find there is the correct one. Matthias, who was an early runner on this assignment, he noticed that the token didn't work. So we had to restart the service, create a new token, and that token should be available for everybody now. So if you have kind of copied the old token, just remove it and use the new token that you find in your secrets project. Good. Should be pretty straightforward, but don't forget to read in the course literature, because you have this, and I will just mention that as well. You have this report.md file, and going to GitLab, we can have a look at that one. Report. You should describe which software patterns were being used in your solution. And it might not only be the obvious ones that it has actually written in the assignment. There could be other ones. So you need to read in the literature, and you will probably, when you read, you will notice that, okay, yeah, I'm using this because I'm using that. So you should probably, I've at least 5, but I think that you could probably identify 8 or something like that. So at least write about 5 patterns, but if you find more, that's good. You should write what is good with using virtualization and orchestration. Why are we doing this? You should write about the session problem that occurred and how you solved it. You should write about how solving the queue problematic and how that is implemented, and you should give some feedback about developing using Kubernetes. How have you done it? Have you been working locally and then pushing and trying it in the cloud, or have you been just like pushing it to the cloud because you didn't get it to work locally? Or how have you used Kubernetes during the development phase? Write short and consistent and clear. So if you're using, say, ChatGPT to help you write, make sure it's not an American long just wall of text with a lot of blah, 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 blah. Be consistent, because otherwise I will be mad. Yeah. Okie doke. That is pretty much it. I have a new meeting waiting. There is a comment. Okay, it was a thumb up. Good. Then I can give a thumb up there as well. I think that's it. Did we have any? Well, I've almost forgot the Theodore problem. It's now called the Theodore problem. Sorry about that, Theodore. But it's when you are on a MacBook M1 or M2 probably, or M3, so an ARM Mac, a newer Mac, there is a problem executing Mats Terraform scripts. And it has to do with some provisioning stuff. I didn't spend too much time on it. However, Theodore did, and he found a solution. And when he wrote the name of the guy or girl who did that solution, Kreuzwerker, then I remember that I recognize this name. So I probably did this like in the summer and forgot about it. So there is a fix. If you run the Terraform scripts and you get provisioning incompatible providers, then check out Theodore's post in Slack. Now I will pin it as well. So it's pinned in Slack, so you will definitely find it. That worked for me, and it worked for Theodore. So probably has something to do with you, Mats, are using kind of new versions of stuff, and they haven't built those for ARM architecture yet. So that's a problem. Last year, on the same note, when trying to install RabbitMQ on an M1 Mac, you will run into a problem. Also, we ran into problems saying that this wasn't available for the ARM architecture as well. So the Helm chart, the official Helm chart for RabbitMQ wasn't available on Mac. I really think this is fixed now because it's been a year, but I haven't tried it. So just bear in mind. So if some of you are installing this locally, like Theodore or someone else on M1 or M2 or M3, please let me know if it works now. I really hope so. Otherwise, you need to do that manually and setting it up using a Kubernetes script instead. And that's a lot more work. But it will work in the cluster on CS Cloud, but not locally on a Mac M1 or 2 or 3. Yeah. So that's it. I think. It was a long one today. You get a big applause from Matthias for your scripts, Mats.
Well, we can, I don't know if I should say anything about those scripts, but don't waste any time to try to understand them.
Because you don't understand them, or is it ChatGPT?
Well, I do.
You do. Yeah. Yeah, it took some time, and it's a lot of fiddling with IP addresses and stuff. Oh, a bit. Well, good. Yeah, thank you for doing that. It works tremendously well. Now I hope that the web application will as well. So I'm eager to get the feedback from Mats when he tries it out now. With that, we need to leave. Diego, you have another meeting or lecture to attend to, and I have to run for a meeting. But we'll see you this afternoon. We have a workshop, so you just show up and we can just use it as a tutoring session at 1:15. So for those of you who need help with anything regarding the assignment 2 or orchestration or Docker or something like that, we can have a look at that. Okay. Have a nice day. Bye.